Carl Sagan once defined the Earth as the pale blue dot. 70% of its surface is covered by water. Life on our planet began in the oceans some 3.5 billion years ago. Since then, water has been an essential component for us. In fact, 2/3 of our bodies are made out of water. We can't imagine life without it. As far as we know, without the presence of liquid water, life is not possible at all. Water is all around us. It's not only in our oceans, but we also find it in rivers, lakes, ice, rain, clouds, even in the air we breathe in, as it's continuously evaporating into the atmosphere.
Water is important for all life. We wouldn't have life on this planet if there wasn't water. When astronomers try to think about other planets and whether they have life on it, the first question they ask is there liquid water?
We have liquid water covering nearly the entire planet, 70% of the planet covered by water. There's water in our atmosphere, in the air, all around us. You don't find any place, any chunk of air in the atmosphere that doesn't have some water molecules or some ice particles or some water droplets in it.
Without water as part of the climate system, we would have wild temperature swings in our atmosphere that would probably make any planet uninhabitable. So water is a key driver.
So water is everywhere. Now, the way water begins, of course, it's a liquid out here, and the sun beats down on the surface and it warms the water, it evaporates it. Just like on your stove, you put your pot of water and your heating element below it heats it up and it boils off, you get steam or you get water vapor. Same way that the sun's energy will warm and evaporate water. That water rises in our atmosphere, and as it rises, temperatures are cooler aloft, and so you form clouds. Clouds are water particles. They're little liquid water particles. Some are very tiny, and they float around as clouds. They can also freeze and form ice particles, and those ice particles float around. Those are also clouds. As the atmosphere moves that water vapor around and those cloud droplets, they fall out of the sky and they come down on the surface and they feed our lakes and our streams. They make the soil wet so that crops can grow. Water is really a fundamental part of our planet. It goes back to the oceans and then it goes through this cycle again. So you get this constant heating up of liquid water, it becomes a gas. It precipitates out onto the land, and it drives this, what we call the hydrological cycle.
So as water comes into the atmosphere, it has a number of effects. So it helps to make clouds, it helps to make rain, but water is actually a very important greenhouse gas.
Also, water carries energy with it. It takes a lot of energy to evaporate water. And then when water forms cloud droplets, it releases energy. So water is a big component of not only the hydrological cycle, the movement of water, but the energy cycle of the planet also, because it's a greenhouse gas and because when you evaporate water, it carries a lot of energy.
So the way it works is when we change the atmosphere, put more carbon dioxide in it, it gets warmer, and that allows the atmosphere to hold more water The water is also a greenhouse gas, so that increases the temperature further, so it's a feedback effect.
Water, being a strong greenhouse gas, will actually amplify the greenhouse gas effect from these other longer-lived species like carbon dioxide and methane. So that's a very strong positive feedback loop which would keep driving the temperature up.
Or you could create more clouds and reflect more energy back to space, which is what we call a negative feedback.
So we have this complicated interaction between the positive feedbacks from the water vapor itself versus the clouds that it forms, giving you a negative feedback. And finding that right balance, that's part of what we're trying to understand with the entire hydrological cycle in the tropical part of the atmosphere.
And it turns out about half of the change in temperature of the atmosphere right now and the change predicted in the future associated with the increasing carbon dioxide is caused by this water vapor feedback.
Water comes and goes, and that's driven purely by the physics of how water works. It's a reactionary greenhouse gas as opposed to a longer-lived stable greenhouse gas. But water's the big player in the entire feedback loops of how the atmosphere works.
So it's very warm here in the tropics, and it's very moist. And so the air down near the surface has a lot of energy in it.
So deep convection in the form of thunderstorms and typhoons actually are more energetic. They go to higher altitudes.
And so it can go quite high. We see these big thunderstorms that develop, and that's this air being funneled up, just like a boiling pot of water. The air gets funneled up into the upper troposphere here and actually go very high.
And so that extends the troposphere upward to higher altitudes, and the temperature keeps decreasing as you go up, and so it's colder.
And so eventually, most of the water gets frozen out as you get up to these altitudes of 50, 60,000 feet. So it's incredibly dry, even though down at the surface in the tropics, it's very wet and moist. It's very high humidity, it's damp. When you get to 55,000 feet, about 16 kilometers up, it's incredibly dry.
You still get some water making it up to the tropical tropopause, and there the atmospheric motions transport air into the stratosphere. So air is transported into the stratosphere with a small amount of water that's left behind, and that's controlled by the temperatures at the tropical tropopause. So if the tropopause is colder, less water will make it into the stratosphere. If it's somewhat warmer, more water will make it into the stratosphere.
Above us, up at 40, 50,000 feet in the tropics, the atmosphere is going to warm up through this century. And because of that, there will be less freeze drying of this air going up. And so the thinking is that water might go up. Now, water is a powerful greenhouse gas, so if water increases at those higher altitudes, it will act to trap more energy at the surface. So it could cause the temperature to actually go up higher.
Climate change will have huge impacts on food supply, on ocean levels and flooding of coastal regions.
So it's important to understand, put all of this together to understand how water will change through the next century.
The more we understand the processes, the better off society will be because of it.
ATTREX, when studying the tropical tropopause, is addressing a key uncertainty in our ability to predict future changes in climate in response to human influences.
It is believed that Guam was first discovered by seafaring people who migrated from Southeast Asia around 2000 BC. When Portuguese explorer Ferdinand Magellan arrived at the island in the 16th century, he found a highly stratified society, experts in the art of sailing and skilled craftspeople, the Chamorro. Since then, numerous expeditions have investigated this region of the Pacific, yet there are still many discoveries to be made and places to be explored. Although this time we'll be looking up, way up into the sky.
Attention on deck, it's the start of my mark.
Box number 7324. NASA 872.